At VetStem, Dr. Carolyn Wrightson, Director of Laboratory Operations, gave us a personalized tour. So my understanding is that these cooling containers have been designed and validated to keep the temperature controlled for 48 hours. Is that correct?
That is correct. 48 hours in and 48 hours out. We've tested temperatures down to -5 for over 6 hours and above 40 C for over 6 hours, and they still maintain their temperature 2 to 8 degrees.
In addition to that, the outer shell of the container is removed to keep the laboratory environment as clean as possible. After the samples are labeled and received, the first step is to wash the sample, and this gets rid of any of the extra fluid during the collection process, reduces any bacterial contamination, and all this work is done in highly specialized ventilation hoods that has very clean, almost sterile air.
While we're breathing the air in this room and it has less than 10,000 particles per meter cubed, this has less than 1 particle. So this is like an incubator for a baby, essentially. And one of the things that our laboratory technicians are trained on in aseptic technique is how to operate within this hood without compromising that sterility. There's a constant airflow through the HEPA filters that are creating that environment so that it's completely sterile.
These are live cells, and live cells can also support live bacteria. You will see that through a series of laboratory procedures, Dr. Wrightson and her staff are ensuring the samples are sterile. How many cells were able to be recovered? And more importantly, what's the viability of those cells? So when you say you're looking for viability or assessing viability, I mean which stem cells survived the process, which ones are still alive and still going to work.
That's correct.
And we're adding a dye to it. The dye is picked up, then we know the cell
is
got
non-viable.
damaged.
Then in the second count that we do, we add a reagent that's somewhat like soap that then goes in and pokes holes into all the membranes. And from that, we're able to get a total cell count. And if you subtract from the total cells those that were non-viable, then you tell what your total viable population is.
Okay.
It's telling me that it's about 90% viable.
Okay. We want to be sure that these cells are available for future use in case we want to treat the horse again or the horse has another injury. Let's say we collected 24 million cells and then I requested 8 million cells. What happens to the other doses?
The other doses will take first a retention sample, and then we'll take the remaining and we'll place them into frozen vials that we store in liquid nitrogen, and they're cryopreserved.
What kind of storage capability and culturing capability does the laboratory have?
So in each one of these we have the rack, what the equipment number is, what box number it is, and we know exactly what sample is in each position within that rack.
Mm-hmm. Cultured cells are available for use in about 3 weeks. The procedure of culturing can provide a lifetime of cells for use.
Yeah.
And finally, the use of adipose tissue by VetStem allows us to get these cells back into the horse within 48 hours, and this limits the amount of scar tissue formation and gives us a better result. We'd like to thank the folks at VetStem for their help in this video production, but more importantly, for their efforts in the advancement of horse health care.